One of the problems with GM's newer Gen 5 range of engines is that they are direct injected. In stock form, that's a great thing, but when we start adding more and more power, it's very easy to run out of fuel capability. And we're here with Michael from Too High PSI to talk about a specific solution that they've engineered. Now, Michael, before we talk about your solution, let's just talk a little bit more about why that direct injection can be problematic. Where do the limits lie?
Well, I mean, basically you have a system which has got injectors in it at one size. It has a mechanical fuel pump which runs off the camshaft. And those both were sized for the basic production engine. They normally leave you maybe 20-30% of extra capacity in there. But these LT engines can handle way more power than that. And the issue is that you run out of fuel pretty quickly.
All right, let's talk about kind of where that limit is in stock form. What sort of power will we be likely to be able to produce with an LT-based engine, maybe with a blower on pump fuel? Because the fuel does factor in here, which we'll talk about more.
Definitely. So if we're talking LT1 with a supercharger, that's the lower power version, you can get to right about 600 horse on a stock fuel system. And that's pushing the limits everywhere. Most kits you'll find will be around 550 to 575. If we go to the LT4, which is the higher output, already supercharged engine, we can get that up to about 700 on pump gas with the stock fuel system.
Now, traditionally, when it comes to direct injected engines, there hasn't been a massive aftermarket supplying larger injectors like we see with port injected engines. Most people watching this would probably think, well, just put a bigger injector in it.
Yeah, exactly.
It's not quite as simple, but there is an aftermarket now supplying larger injectors and pumps for these engines. That's one viable option?
Yeah, definitely. I mean, there's 30 over injectors that a lot of guys use. If you use those, you have to get more fuel pump too. So you're going to have to put a camshaft in the car with a bigger cam lobe to move that pump further, and possibly a bigger bore pump to get more volume out of it.
All right, let's come back and talk about your specific solution and what does that involve?
Okay, well, our system is basically a hybrid fuel system. We've taken the DI system and added port injection to it as well. So we continue to use all the capacity, all the benefits of the DI system. You know, you get your in-cylinder cooling, detonation prevention from that, and then we add the homogeneous charge of a port injector under high loads to supplement that, to make sure you can keep going.
Okay, so there's two challenges as I see it with this system. The first is the mechanical installation, physically getting a set of port injectors into what is already a very tight engine configuration.
Correct.
So let's start with that. How are you managing that?
Okay, so we do basically for most supercharged and for naturally aspirated or turbo applications, we have a set of port plates. So most intake manifolds or superchargers for LT engines don't have any way to put port injectors in. So we have a port plate, which if we want to see it, it basically sandwiches between the supercharger and the cylinder head, and it holds the port injector.
Okay, and then does that allow the use of any of the usual range of aftermarket port injectors, or does it have to be matched with something specific?
The only thing that's critical about it is the length of the injector. Depending on the application, we have different lengths that are required. But yes, any of the large port injector manufacturers, we use their parts exclusively through this.
Okay, so that's the physical installation. We also need to get the fuel to the injectors, and there's obviously fuel already running to the high pressure DI pump. Correct. So are there any complexities around getting that fuel also supplied to the rails for the port injectors?
For the most part, no. It just pretty much will connect right in there. We splice into the factory line coming up from the back of the vehicle, and then at that point, we basically feed the fuel rails and then feed the high pressure DI pump in the back, at the back of the engine.
Okay, so that covers the physical installation, getting the fuel to the injectors, but then we've got the control element, which is absolutely just as important. Obviously, that factory engine management system there is designed and expecting to run the factory direct injectors. So how are you then adding the fuel through the port injectors as well?
Okay, so once the injector is installed, we have fuel to them for the port injectors. We have a controller, which is called a Reflex Plus. It's a relatively nice, simple port controller. It does have a lot of capabilities, but initially we're only using it for injecting the fuel. It is full sequential, and it uses the CAN bus and two inputs, the camshaft and the MAF meter, to basically control all the fuel into the engine.
Okay, so there's a bunch to dive into there. Let's start with the CAN bus. What information is it getting via the CAN bus, and is this just directly connected to the factory GM CAN bus?
Yes, it basically tees into the CAN bus. When you install it, we provide a plug-and-play solution for that. Once CAN bus is in, you can get everything that's basically available on the CAN bus. We don't request anything off the CAN bus, we just receive the data that's there. So flex fuel, engine RPM, manifold pressure, I mean, any of those variable items you'd like to have are all available on the CAN bus for us to access and use with the controller.
All right, so from there I will assume that you can use some laptop tuning software to physically set up a table of supplying the additional fuel. So that is a way of solving that problem. Obviously gets the fuel into the engine, but the integration then with the factory ECU, I mean, the factory ECU doesn't know you've got this auxiliary unit, doesn't know extra fuel's being added. Now on face value, I could imagine there being some complexities around there. So can you tell us how you deal with that?
Sure. Well, to begin with, we run completely off the MAF meter, same way the E92 GM computer runs. We also use all the same strategies that they have in there. So our controller has a MAF curve in it, it has a power enrichment in it, it has an injector size, of course, for the size you're running, air fuel tables based off of your alcohol content, all that's the same as E92. You basically have a duplicate in this. And then we have a calculator, which is an Excel spreadsheet you could download from our website, and it basically takes the input data from the E92, and then you just tell it how much port you'd like to run. Say, for example, 30%. Put that in there, it will give you new curves for the E92 and new curve for the Tuner Pro. You can copy and paste those right into the two devices, fire it up, and you're probably gonna be very close for what you need, and you could tune from there.
Okay, so just to back that off a little bit, you use the term MAF there, so mass airflow sensor. So
yes,
that, as its name implies, tells the factory ECU, and in this case also your auxiliary module, what the mass of air entering the engine is. Obviously, we need to know that in order to know what mass of fuel to deliver to get a specific air fuel ratio. So nothing too crazy going on there. I'm assuming what you're actually doing then is kind of cheating the MAF curve back inside of the factory ECU past the point where you're introducing port injection. Is that correct?
Correct, that's right. So we'll reduce the amount by whatever percentage we put in there, say 30%, we'll reduce the MAF curve. The calculator will do that. So that does what, you know, if it's an automatic transmission car, you're gonna have additional complications there that you'll have to work a little bit with some of your torque management to get that back up to where it needs to be for what you removed from the MAF curve. But other than that, in small instances, it's not very difficult. When you get to high volumes, like 60% port, then you'll have a little work to do. Your homework will become important.
So again, just to back that up a little bit there, so that calculator is really taking all of the heavy lifting out as far as the tuner is concerned. It's giving you a new curve to put into the factory engine management system.
For fuel. Yeah.
Okay, so that keeps everything happy. But as you mentioned there, as you're essentially under-reporting mass airflow to the factory ECU, therefore its torque calculations are off. It essentially thinks that the engine is making less torque than it actually is. So that's where you need to go and do a little bit of extra work.
That's right. That's correct. You need to get back up to the output that the engine's providing, and you generally do that from the dyno.
Okay, in terms of limitations and power, are there any? What have you seen out of these kits in the real world?
I mean, for the most part, most cars that we do are generally above 1,000 rear wheel horse. We have some more simple cars that still run stock LT engines that are right at 700 rear wheel horse. That's pretty much the safe limit for an LT1 on full E is about 700. You go much over that, you're gonna hurt pistons, even just under a load. But anything that's a good built motor, it's no problem. We have cars up as high as 1,440 rear wheel horsepower. And they, of course, are more extreme drag cars at that point.
And I'm guessing if you wanted to go further, it would simply be a case of fitting larger port injectors?
Exactly. I mean, most guys will run up to about 1,000. We do have some guys with 170s in them. That's a lot of port injector. They're probably only running 50% duty cycle, but with a goal of 100 someday. So
everyone needs a dream.
Got to have more power.
Michael, thanks for giving some insight into the product. If people do want to find out a little bit more, where are they best to do so?
Sure, they can find us on our website, toohighpsi.com, and it's just TOOHIGHPSI.com. Thank you.
Perfect. Thanks a lot, Michael.
You bet. Nice talking to you.
If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.